slowly but surely. It's about time. And I suggest before we move on with presentation, we would clap a little bit for the volunteers and everyone who arranged the conference. It's a lot of work, and the work of volunteers is not always appreciated. So let's give a round of applause for volunteers. And well, with that done, let's get to the presentation, which is called World Configuration as Code via Terraform, Stories from Trenches. And you know, before we start, this a little bit of introduction. I'm a father. I'm having a daughter, 3 years old, and I'm always looking for the ways to develop her creativity, attention for details, and you know, like those books that let kids to find differences between pictures are very fun. However, I also have colleagues that, well, time to time make me find differences on production servers just because they do things, and that's not fun at all, especially during outage. I mean, you want to figure out what went wrong, and the less the difference is, the faster you can resolve the issue. And then just imagine you actually having an intrusion. You have a security incident, and now you're part of a response team. So basically, every change to production server raises the question, was it done intentionally by someone from your team, or is it an intruder changing things around? So those are hard questions, and the best thing to deal with them is not to have them. I mean, to avoid asking those questions completely. And approach to do your infrastructure as code, and this is what this talk is about. How do you use Terraform Vault to do infrastructure as code for the HashiCorp Vault? How you use HashiCorp Terraform to do infrastructure as code for HashiCorp Vault. I usually sound much better, but well, got a little bit of cold, so sorry about that. And there should be a slide with my name on. Oh yeah. For some reason they mixed. Anyhow, about this presentation. I'm not pretending to be an expert in the topic, so I'm just a practitioner helping companies to go about those problems. So I'm sharing what's working for me, for my clients, what doesn't. So there will be technical details and Terraform listings. So don't be stressed about that. If you want to have those, the slides will be available later on. The organizers, I just copied the slides, so the PDF will be available. And my name is Andrei. I'm a technologist with more than 10 years in the industry. I write tools, I fix projects, develop people, actually, time to time. Also hosting meetups and the conferences. Currently, I'm based in Las Palmas de Gran Canaria, so I'm running cloud native meetup groups there and HashiCorp user group there. So if you are from Las Palmas and you want to talk on a meetup, come talk to me, because we are looking for speakers. I do trainings, teach people and various things like Git, Docker, Kubernetes, Jenkins, and so on. Continuous delivery was something that I spend a lot of time teaching. And have plenty of certifications, but it's not that important for this presentation. So Terraform. How many of you knows what Terraform is? Almost everyone. For those of you who don't, it's a tool that could call your cloud provider API, not only cloud provider, other tools. So Terraform has plugins, and every provider is basically a converter of Terraform DSL to API calls to the tool you're using it with. So then you could use Terraform configuration language to describe your infrastructure in a declarative way. Then you would run Terraform plan, and that will show you what it's about to create. And then you run Terraform apply, and it actually creates it. It also traces dependencies between resources, so it's intelligent and can create resources in the right order. So for instance, you first create VPC, and only after that you create security group in there. It could be used to automate change management. There are tons of open source models that you can think of them like libraries that you could pull from GitHub, and then you would use someone else written Terraform spec to build your infrastructure, which saves a lot of time for you. And you could build on the best practices built by someone else. And the good thing is that Terraform nowadays has a providers for almost everything. So, for instance, it has providers for all public clouds you can think of, Cloudflare, for almost anything. For GitHub, you can have your GitHub using Terraform, your GitHub organization. So you could basically describe almost everything, which is nice. Vault is another tool from HashiCorp, and that's used to centrally manage secrets, to reduce secret sprawl. Just yesterday I gave a presentation at HashiCorp User Group Madrid, where we were using example of database credentials. Like in many organizations, you have a database, right? And you store some data in there, and you have like only one login and only one password for that database, and everyone have it. Like your developers have it, your operations have it, your application servers have it, and when someone goes into database, there is no way you can audit who went to the database because everyone is using the same login, so it's faceless, basically. You just know that someone came in and exfiltrated your data. Who that was? Well, that's a good question. And Vault is actually allows you to go away from that, and you could say, Vault, I want to log into database. Give me a temporary database credentials, and then Vault would go into the database and provision temporary database credentials for you that you could use to log in, do something, and then they will be TTL, time to leave, for those credentials, which means that depends how you configure. Let's imagine you ask for a read-only credentials that are valid for 1 hour. Within 1 hour, if you do not renew those credentials, Vault will go in and revoke those credentials. So even if you post it all over the place, to Slack, to your mama, to your GitHub, wherever you post it, it's not a biggie because it's a very little opportunity window. I'm not saying you should do that. I mean, don't post your connection strings to GitHub. Don't get me wrong. It's a totally bad idea to do that because there are bots that constantly crawling that GitHub for AWS credentials and other stuff. So, but what I'm saying is that you could go away from static credentials to dynamic on-demand credentials. And everyone gets their own credential set, which means that you could do a better audit about who accessed the database and why they wanted to do that. And it applies not only to databases. You can get like temporary credentials for many things, and we're going to see it. And another thing is that Vault provides you a break glass procedure. So imagine like if you have only one database credentials for everything, you cannot revoke this because you're going to break more or less everything, right? You're going to break your production and who knows what else. But if every entity gets its own credentials and some of those credentials gets compromised, then you can only revoke those and everything else keeps running as it used to be. So really nice thing. And also it helps to narrow down where the compromise is. So let's imagine I convinced you that you want to have Vault in your organization. Where would you start? A good idea is to collect requirements and clarify context. Those are questions you can ask. How am I gonna install Vault? What is the infrastructure available to me? What is the common best practices in the company? Maybe you're running VMs, maybe you're running containers, maybe you're running ECS or Kubernetes, maybe you have bare metal servers. All organizations are different, so you have to start there. Then how do you maintain Vault? So the question here is, would you patch the server or the things that Vault runs on, or would you build the image and just redeploy, like doing immutable infrastructure type of thing, right? I strongly advocate for the second science, when you're just trying to maintain the server and like doing the patching, something with login, install patches. There is no guarantee that there is no configuration drift. It's much safer to have the images built, and when you want to change something, you just change the image, you build a new image, you delete old image, you deploy a new image, and you know it's exactly as you envision it to be. There is no configuration drift. Disable SSH, even in some cases, so people cannot change it. Yeah, so then how do you access it? That's the question you ask. And then how to unseal. So when the Vault comes up, it's sealed. You cannot use it. And when you initialize Vault, it will give you, by default, it will give you a set of 5 keys, like the gibberish strings, and you will need to have 3 of those to unlock the vault. So Vault will use 3 of those to reconstruct the master key that is used to encrypt the database of the secrets. So, and that's kind of, it's inconvenient. If your vault restarts during the night, you need to find at least 3 people, so they go into the console and, type vault in it and pass their key. This is not how modern IT works, right? Or maybe it does in some companies, but hopefully not yours. There is a way to auto-unseal, so you can say, vault, rely on my cloud provider to store the key in a KMS and use KMS key instead. So, and then Vault can, when it boots up, it could access a KMS key and do decryption of the master key. Then how do you get initial secrets, for instance, TLS certificates into the entity that runs Vault? And also, what is the storage you have? Where do you stream logs? Where do you stream telemetry? Because what you want to have, you want to eliminate the need for anyone, operations or developers, to go to the Vault box, since it's a place where your crown jewels are. And because of that, you want to get everything out of it. So if someone wants to see the logs, they should be available outside of that box. If they want to have telemetry, it should be outside. If they want to have audit files, they should be outside, and so on and so on. How would you run it? Is it like high availability, multi-data center? Valid question. Would you have one vault per all environments or vault in cluster per environment? That's also a valid question to ask. So something to consider before you start doing it. Look for the best practices and examples. The good thing is that there are at least 2 known Terraform models that would create a vault setup for you. That's a good start. Probably they will not be exactly as you want it, but it's a good start. It's a lot of boilerplate code already done for you that you could just fork and start change, so it fits your needs. There is also the Vault-Helm, so you can install on Kubernetes, and there are a lot of great resources at learn.hashicorp.com where you could learn more about how you operate Vault. Then you want to harden it, because this is where all your secrets are. I will highlight a few things like TLS termination. Apparently there is a common misconception. So you would have your load balancer in AWS, and that load balancer, you'll specify your SSL certificate, right? Which means that TLS connection being terminated on your load balancer, and the rest from load balancer to the box goes unencrypted, because you terminated TLS connection on a load balancer. Don't do that. Just do SSL bypass, do just TCP bypass, send it all to Vault, and let Vault terminate TLS. I realize that it's not always clear for everyone, but don't terminate on, at least for Vault, don't terminate on the ELB. And there are a lot of things. And again, learn.hashicorp.com, a perfect place to start. Another thing that is not, I would say, obvious, is that audit on, which means that the audit logs are disabled by default in Vault. So you want to have those on, and then they usually being stored on a disk, so you need to find a way to stream them to somewhere else. For instance, upload them to S3 bucket, and when you do upload them to S3 bucket, you want to have this bucket to send those files to some other account, like a black hole. So anything inside this account cannot access them, because if you have intruder trying to hide what they did, they will go after those audit files. And by, for instance, doing the logs replication, one-way logs replication to another account, then you're preventing that from happening, because you have a copy of the audit logs untampered, hopefully, in another account with another S3 bucket. So some good ideas here. And then this is what I learned hard way. It's a really good idea to split Vault deployment Terraform spec and a Vault configuration Terraform spec. You might ask, what is the difference? The difference is what APIs you are calling. So here on the top, you're calling your cloud provider or whatever your infrastructure provider is. Here, you're calling Vault APIs. If you have it all together, when you're applying a change, for instance, you're doing the rolling deployment of the new IMI image to EC2s, what might happen, Terraform will be calling both AWS and your Vault might blink at some point and lose connectivity for a second. And exactly in that second, your Terraform tries to contact the Vault via API, it's failing, and Terraform stops. It says, I cannot continue, your Vault is not there, and you're left in the middle of something, like in a no man's land, because your infrastructure change didn't finish, and you applied some changes to Vault, but not all, and you have to go and sort this mess out. So what I would recommend, you do changes to Terraform as a server, as an infrastructure, separately from configuring Vault itself. So you do changes via Terraform to Vault as a server, separately from configuring Vault itself. So Vault is up and running. What do you do next? Then you would start configure it, and you would need to have certain things. You would need to expose all the URL via Vault other environment variable. You will need to have Vault token, and it doesn't hurt to have a good idea what you're after. And we're going to discuss that in details. So when you just initialized Vault, you will get a root token, and that's like a God mode token, so you could do whatever you like. And the good idea is to delete those once you don't need them, because it's hard to steal from you something you don't have. And you can create new root tokens using those 5 keys I mentioned before. It takes a little bit of manual work, but it's good, because then you know that no one can issue the root tokens and run away with them. So like the same with AWS infrastructure, right? Your AWS root account, how do you secure that? You just create some long password and don't save it anywhere, because then it's impossible to steal that password from you, and you can always reset the password if you want to, if you have access to the email address that was used to create it. So that's how a token would look like. You get a token, and the token itself is this line of things. It will have policies that you cannot see behind this white line, but we're going to talk about them. The token will have TTL, so it will have issue time, last renewal. You can renew token. So if you want to keep using token, you just say Vault renew token, and token keeps valid, not being renewed. And you want to do that because every temporary secret you issued using your token has a hierarchical tree starting on your token. So if your token being revoked, everything you created using token being revoked as well. So that's why when you get a token, you want to keep that renewed while you need it. So for instance, this one was created for 8 hours. It's like, this is how we made it for developers. Developers in the morning will type some command, and they will get a temporary token which is valid for 8 hours. In 8 hours they go home, token revoked, everything they created using that, for instance AWS credentials, revoked as well. And this is a slide that I'm using to explain Vault and all that it has inside. So on the left you have auth methods, and you would use auth method to talk to Vault to get a token. So Vault need to validate who you are. You're basically doing like login to Vault, right? And you can do that using LDAP. In return, you get a token. Token have a set of policies, and policies define what you could do. For instance, you could get a database login credentials using those policies for a certain database, or AWS access keys, or RabbitMQ credentials, or the KV suggests a key value store, and then you can read secrets from there. So those are not static, but you still have an audit of who did read the secret. And then when you want to delete a secret from the KV, you can go to audit and see, is anyone reading those at all? Then they're just dead weights that you could remove. You have a transit secret engine, which is really nice. So you could use Vault as encryption as a service. And I know that some companies that are trying to comply with GDPR using that to encrypt the data inside the tables. So they encrypt the database itself, but also what's stored in the database rows is also encrypted. So if you steal the database, you cannot read it. And if they need to forget the person, they would delete the salt that was used to encrypt those. And then you don't need to remove the row from database. And this text is unusable any longer. You cannot decrypt it. You technically forgot the person. And there is also a built-in PKI infrastructure, which is nice. So we start on the left with auth methods and policies, which is boring, hard, but it's important. And you probably will need to have multiple auth methods. You will need something for humans to come in and get the work done. You will have machines, you will have things. So there is maybe a wrong wording. So machines, by that I mean like your Slack bots, your CI/CD, and by things I mean like application and maybe something running in your infrastructure. And as you can see, like this is just a snapshot of the currently available auth methods, and it's not ends here. There is like it goes down, 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 down. So there are a lot of stuff that you could be using. So for instance, you could be using GitHub, Kubernetes, Google Cloud, like a lot of stuff in there. And then you define the auth role, auth method, auth role, and then the token with policy. And we're going to see how it translates to LDAP. And using LDAP is nice because it leverages existing IAM system where you already have data about everyone, so you don't need to really store anything in Vault for that matter. And you would configure it this way. So we're defining resource on Terraform, which is Vault, LDAP, auth backend, and you say that your server is here, this is how you find users, blah, 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 that's an account to access it, that's a password, you pass it as a variable, and so on. So like, typical LDAP configuration. You're probably familiar with that. And a word of caution, every secret you pass to the Terraform being stored in the Terraform state, so you need to protect Terraform state as well, or keep that encrypted. Then you would create, in case of LDAP, it's not really a role, it's called backend group. And what we're saying here, so everyone who comes to Vault with LDAP credentials and member of the group DBA should get policy DBA on their token. It's not necessary that your group name and your policy name are the same, but it's just easier for everyone to understand what's going on. And then the policy, so Vault is API based, so basically policy defines what API you can call, what path you can call, and what action you can apply. So for instance here, you can say like everything that is under secret, you can create, read, update, delete, list, so like admin rights basically. And then you create the policy like this that will be applied to those credentials or the token that you get. Right, and that's a funny thing that you will need to have a policy to manage policy. So when you start with a root token and you can create everything, but you're not going to use root token for the rest of your life. So you're going to revoke it, hopefully at least stop using it, which means that you will need to get a policy that allows you to manage other policies and this policy as well. So that's why I'm saying the policies are hard. It takes some time to wrap your head around it. Then you have deny by default, which means that if something explicitly not allowed, then it's not allowed, it's blocked. And as I said again, it doesn't have to match LDAP group name, but it's a good idea so they match. And multiple groups will translate into multiple policies. So for instance, if I'm member of DBA and I don't know, management groups, I will get policies that corresponds to those combined. So it will be a set of those two. Things to consider, you want to look into those. For instance, make sure that you don't have a default policy because it might contain some rules that are not wise. Then a good idea is to have token-bound CIDRs. So you could only get token if you're coming from a certain IP address. Another way you could address that in a more like zero trust approach where you would use MTLS with Vault. So everyone who is trying to access Vault has to have valid SSL certificate, and they will be authorized to actually call Vault before they even authenticate in there. Then you define the token TTL and the max TTL, meaning that for how long it can totally leave. And this depends on your organization. But those are good considerations. Don't fall to defaults in there because this is important to think about. Uproll is another authorization engine that you could be using. And I think the primary use case here is for the hosted CI. For instance, if you use like Circle CI in the cloud, right? Your Circle CI need to log into Vault, but there is no other IAM system it can leverage because Circle CI doesn't really know anything about your infrastructure. And Uproll is basically username and password. So you give the Circle CI, here's a username and password, use them to log into Vault. It's, again, brings us back to the problem that we discussed with database credentials. It's technically a bad approach, and I would advise avoiding it when you have a chance. But however, if you don't, then you create it this way. You create a backend, and here you say, for this backend, we create a role, and that role will get those policies. And then you would do like this. You would say vault write -f, blah, 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 secret ID. And that will give you a login. And oh no, that's actually you're accessing a role, and that gives you a password, and a role ID is your login. So you use this string and this string as a login and a password. Login being this one, a role ID, and this one being a password, a secret ID. So you use those to log into Vault and get a token with the policies you just described in Terraform. And another way, you could use Terraform to actually create those and store them in KV. So you're creating the secret ID for this backend, for this role name, and as you can see, I can refer to other resources in Terraform saying that, well, get this role name, because then I'm not thinking about changing role name everywhere. I just change it in one place, and I have those computable references to them, and I don't need to think that I need to go through all the files and change it everywhere. And then you create a KV, which is a map that contains, well, that's basically a map declaration here, which is called KV, which will contain your role ID, secret ID, and we store that to the actual KV in Vault, so you can go and get it using Vault UI or CLI. Then clouds, IAM, for instance, Kubernetes as well, is very useful when you for your non-interactive authorization, so for instance, for your applications. We're going to look on how IAM works. I did a presentation about how Kubernetes stuff works yesterday, so there is a recording online if you want to. I think I'm going to have a link to that here as well. So with AWS, you do role again. Here we're saying the CI, and the token is going to be valid for 1 hour. Get those policies, and then you need to create AWS user. Why would you need to have AWS user? You need to give Vault some credentials, so Vault can go to AWS and check stuff for you. So that's why you need to have AWS user. And we're creating access key, we're creating AWS IAM user policy. It looks like this. It basically allows you to describe users and roles, and we're going to see why we need it. And then we're creating something which is called client, where we just tell him for this backend, use access key and secret key to validate all queries. And basically what happens then, you will be able to send a signed request to Vault, and Vault will validate that AWS signed request for you by going to AWS and saying, there is someone with this role trying to get in. What should I do? Is it valid? And if it's so, it will return the token with the policies, which is quite handy. So you can use the instance profiles to actually authenticate into Vault. The same works for Kubernetes, so you can use Kubernetes service accounts. And that's a recording from the last year, the talk I did at Hash Talks 2019. I have updated talk with the slides, so if you need the slides, I could send them to you. Right, so now you have a token. You can authorize. You don't need root token any longer. What do you do next? You do secret engines. So you see like there are a lot of stuff. You could do AWS, Azure, Console, databases, Google Cloud, a lot of stuff. Even SSH key. So you can get a temporary SSH key, and Vault will place that SSH key where you want it to place. So quite convenient. And you just start configuring those secret engines. And I do not recommend configuring everything at once. Just solve one problem after another. Like for instance, if your biggest headache is database access, you need to pass security audit for PCI DSS or something like that, making sure that you actually can show who accessed the PII, and then you start with that. You work with a database secret engine. Or if your pain is AWS temporary credentials, you start with that. So what, for instance, I did for the client right now, we wrote a small Go binary that they would run in the morning. All developers run that in the morning. Well, I also run that binary in the morning. And that binary will go in, authenticate me in Vault using LDAP. I will get token. Then it will automatically provision AWS credentials for me, which are valid for 8 hours, and export them into my shell. So I'm ready to go. And onboarding of new employees becoming super simple. You don't need to create user accounts for them because they get all AWS keys automatically as soon as they run this command. And then what we did on top of that, then you use those temporary keys to generate signed request for AWS to log into Amazon. So you can generate signed URL that you passed into the browser and you automatically logged in. In this way, we don't have any static credentials whatsoever for AWS, which means that we don't need to run after our developers saying, well, change your password, use MFA. No this headache at all. No SSO, which is hard to set up in most cases. We just generate one-time logins, which bound to the temporary credentials, which bound to the token. So as soon as token being revoked, everything just invalid any longer. Then the key is a key value, as we said, quite easy to create, and you might want to have two types of those. You might want to have one for the humans to put stuff in, and humans, us, we are messy. We don't follow patterns, rules, we make mistakes. So that's why you just create something for people and say, put your stuff in here. And then when you want to have repeatable storage of secrets for machines to read from, you can use Terraform to create those and read stuff that people save here, which is unstructured, and create predictable structure. So it will be another KV, which is generated automatically by Terraform, and you know that its content is predictable. It's generated by machines, so there is no surprises in there. And with AWS Secret Engine, again, you need to have another user. So when I said we don't have any static users in AWS, I meant we don't have any static users for developers or like humans, but we still have a couple of static users for Vault to use. And again, we're creating the user, we're creating the policies that would allow Vault to create those temporary users and temporary keys, and also delete them later on. And we're creating the backend where we say, well, so use those credentials. We're setting default TTL, and we're defining the roles. So we're saying there is a role admin. When people log in as admin, then they would get a certain AWS policy attached. Here you can see it. We say, when you're coming with this role, you're getting those roles attached, assumed, basically. And you could have like a read-only, for instance, or depending on department, which is quite nice. And then when you just run it like this, you get your temporary credentials. But it is something for developers to remember, which is you probably don't want them to do. Write some tooling to make their life easier and to do a right thing, because especially like login strings, they might be quite long. And this is how you can, if you're interested in what I described, how to use temporary credentials to generate sign-in URL, that's a guide. And you're going to get slides, so you have a link. Also, I do recommend watching this guy. It's amazing presentation. He describes what they do at Hootsuite. And they build a lot of tooling around Vault to make developers productive. And I really like this presentation. Last year at HashiConf EU. So definitely recommend checking this out. So database credentials, and those are hard because when you're configuring the database secret engine, again, you need to provide Vault with credentials to manage your database credentials, right? And you need to provide creation statement, revocation statement, renewal statement. And those are hard because imagine you giving your application temporary credentials. What applications do? They go to database and run migrations, right? And in scope of that migration, it would create a new table, for instance. And then you have a problem because this table is being owned by those temporary credentials. So when you're trying to revoke those credentials, you fail because those credentials own something. So in your revocation statement, it should be very clever. You need to say, well, for every possible thing that those credentials might create, you have to transfer ownership to this user that is static inside, which is hard. I mean, I spent a couple of hours to get those right. And if you have DBA around you, then, well, use his help because it's hard. If you have some other means, I would suggest considering something else. For instance, RDS IAM. If you have a temporary AWS credentials, you can use those credentials to sign in into the RDS instances and get the same benefits. You will still have audits through CloudTrail, and it's still like ephemeral credentials. The secret rotation. So let's imagine you went in and configured database credentials for the Vault, and then you want Vault to actually rotate those for you, and there is a way of doing that. In that way, that root password you gave to Vault will be changed by Vault, and you don't know root password any longer. So the Vault is only place that knows root password. There's a little bit of bash thingy that calls Vault CLI and goes over the database connections and calls rotate root API. You could do that. You don't have to really. So, and then people ask, what if I actually need to go to database using root credentials? One option is to have a Vault with a policy that allows to create the new root-like credentials, or you still have RDS access and you can go and change the password in console, and now you have a password again. For IAM stuff, it's a little bit more complicated. I would suggest doing it this way. So you could say Terraform taint and then resource name, and then you can run Terraform apply. Terraform will recreate those resources for you. It's possible to do via the Vault API, but then Terraform gets confused a lot. Since Vault will go in to AWS, delete the credentials created by Terraform, create new credentials, and start using those. But next time you run Terraform, Terraform says, whoa, someone deleted the credentials I created. I'm going to create new credentials and give those credentials to Vault. And now you have two sets of keys attached to the same user. Next time you rotate, you will end up with three keys, which is by default impossible in AWS because default limit is 2 keys. And the whole thing is crashing a little bit. So that's why I would suggest you do something like this. And also, all the keys you created are saved in a Terraform state. So do protect your Terraform state. Encrypt it if possible, and make sure that no one can get their hands on it. Unexpected findings. So there is a KV state issue when you work with the KV via Terraform. You might create the KV, and then you use something called data resource in Terraform, and data allows you to read something that's not created by Terraform or like by this Terraform spec exactly. So we're saying like, well, go read this KV from Vault and then use those values in here. So what happens is Terraform reads the KV, saves it to state, but then it doesn't reread it afterwards. So if you did manual changes to KV in UI, you run Terraform again, trying to access the new key and value you placed there, and there is no value like that. And it's puzzling when you first time bump into this. I'm not sure where the problem is. I think it's how the Terraform works. Maybe they will fix it. But currently the way around it is to go Terraform state RM and then pass to this data source, that will force Terraform to reread it. I was trying to use Terraform refresh. That didn't really help. So only removal actually helped. But, well, if you bumped into something like this, you know, because first time I spent a considerable amount of time trying to figure out what's going on and looking very stupid in a developer's eyes who came to ask for help. And like, that should work? I don't know. So the final thoughts. Vault introduction is a journey. Don't try to, solve everything at the same time. Pick the most critical use case for the business where it will deliver the most value. Then doing it as a code is the most safe way and repeatable. And then, reuse and share everything just available. And I'm emphasizing reusing and sharing again, because all those tools are new and there are no best practices as such. So we need to have a communication across practitioners and vendors like HashiCorp to define those, because the better we are in using those tools, the more secure the end company is, the more secure the user's data, and we don't want to lose users' data, right? And there is still some glue needed, but HashiCorp went a long way with the Vault support and Terraform. In 2018, I attended the official training for Vault, and we asked Vault engineers, how do people configure Vault? And they say, well, they write a bash script, and they would just run Vault CLI one line after another to configure Vault. It have changed dramatically. Like 2 years later, you have a rich Terraform support for almost all resources you can think of in Vault, like generally used resources. So Terraform is a great tool for that. And if you attended the Pulumi presentation, Pulumi is using Terraform providers underneath, so which means that you could use Pulumi to do exactly the same thing. And as I said, we need to keep the best practices, so keep learning, keep sharing. And with that, I close and open for questions. And if you have some other questions, if you feel shy, not ready to ask it right now, that's my contact details. So feel free to contact there. But if you are not shy, let's go through your questions.
Would you use Hi. HashiCorp has Consul as well, which can be used as a storage engine for Vault.
Yeah.
We're looking to use Vault for storing secrets, database stuff, usual thing. Would you think about using Vault for storing non-secret data as well, or would you split secrets in Vault and configuration data in Consul?
It depends. It's like a common question, answer, like it depends of what you got. Like if you got Consul, then maybe, why not? Currently, in the company where I'm helping at, we don't use Consul, so we just store everything in Vault. And it's easier for developers because they know, like, if I need to get something in Terraform, I can go and get it from Vault, so they don't need to crawl another place. We've been using the secrets parameters manager, parameter store in AWS, I think it's called. But I believe since then, AWS released Secret Manager, which is somewhat similar to Vault. I have a feeling that actually it's like a AWS wrapper around Vault, and they actually run Vault behind the scenes. But yeah, so answering your question, it depends really what makes sense in the company. If the Vault is the only place, use that. If you have a better place, which is already integrated into your life cycle, so why not? Just discuss with your developers what is more convenient for them, because in the end of the day, we want to enable the developers' productivity, right? So we could have a faster time to market and solve business problems.
Okay, but there's no reason you couldn't store configuration information in Vault as well as secrets.
Yeah, I mean, you have a key, right? Yeah. You could just put whatever you like in there. And also you will have, well, the static, still you will have static secrets, like for instance, you're buying validated SSL certificate. There is no way you can automate provisioning of those because they are validated by humans. So you just get them as a zip file, you need to store it somewhere, and you put it to KV. And then it would make sense to, if there is something more needed, well, you put it there. Well, actually, with a cell certificate, you could use PKI infrastructure. So you do not distribute key, the initial private key, and then you will just create a chain of the SSL certificates.
Okay, thank you.
Welcome. Well, looks like it's lunchtime. Thank you for coming.